Today we're going to be talking about Newton's second law of motion, and these are the video notes that are going to go with this new law. All right, so Newton's second law says that a net force acting on an object causes that object to accelerate in the direction of the force. So if I go outside and I kick a soccer ball, the soccer ball is going to go in the direction that I kicked it. So over here, you see the ball is going to accelerate in the direction of the net force that the mallet applies. So, if the object has a greater mass, the greater the force is going to need to accelerate it. So if I have, let's say, a rock, and I'm trying to move the rock. If it's a small rock, let's say it's like 5 pounds, it would be very simple for me to move. But if it's 500 pounds, I'm going to have to put a lot more force into it to get it to move or to accelerate in that direction. So the greater the net force, the greater the acceleration is going to be. So if I put more force towards pushing that rock, it's going to move or have a greater acceleration. So we're going to be able to calculate this. Your formula is force equals mass times acceleration. We know that force, the symbol is F, mass is M, and acceleration is A. Your units for force is newtons. Your unit for mass is kilograms, and your unit for acceleration is mass divided by meters divided by seconds squared. So you have your example 1. You are pushing a friend on a sled. You push with a force of 40 newtons. Your friend and the sled together have a mass of 80 kilograms. Ignoring friction. So don't think about friction that we've talked about before. What is the acceleration of your friend on the sled? Okay, so we find out what we have. So we know force is 40 newtons, and we know the mass is 80 kilograms. So we're looking for acceleration. So we have to rearrange our formula. So we know that we need to get A by itself. So we have to divide M by both sides. The M on the M times A cancel, and so we get F over M equals A. So our acceleration would be 40 newtons divided by 80 kilograms, and we get 0.5 meters per second squared. And we're going to get to practice this a little bit later. Now, weight is the force of gravity on an object. So gravity is always the same. It never changes. It's 9.8 meters per second squared. Never changes. And it does not like weight, your mass is not affected by gravity. You only are going to have the same gravity no matter how much you weigh. So, we're going to find the weight of a suitcase that has a mass of 42 kilograms. So we know our 3 variables, force, mass, and acceleration. We know our mass is 42 kilograms. Our acceleration is always going to be gravity, which is 9.8 meters per second squared. So we're finding force. So our formula equals force equals mass times acceleration. We multiply the 42 times the 9.8, and we get 411.6 newtons. So that's how, if you're finding weight of something and it does not give you acceleration, you know that you're using gravity. All right, so here is an experiment. I want you to go outside, and I want you to get a rock, and you're going to take a piece of paper with you, and I want you to wad up the piece of paper and make it into a ball. And I want you to I want you to get a bowl of powdered sugar, or you can do flour, or you can do just dirt or sand. You don't have to use anything that's at your house right now. That's okay. Just go like on a soft surface, and I want you to drop the rock and the piece of paper at the same time. And I want you to tell me in the Google Classroom assignment which one hit the ground first. And I want you to explain to me why you think what happened, okay? Now, on your Google slide, or on the slide right now, it's talking about different masses, like which one would create a bigger crater. And I want you to read through this, and I want you to answer. I want you to try to understand why the impacts were the way that they were. Okay? All right. Hope you have a great day today.